The silence has finally been broken. After weeks of mounting anticipation and a storm of wild speculation across the internet, NASA has officially opened the vault. The agency has released the definitive visual record of the interstellar traveler, Comet 3I Atlas. For weeks, the global astronomy community was left in the dark due to a pause in public updates caused by the United States government shutdown. This lack of information fueled a firestorm of theories. Was the object behaving strangely? Was it artificial? Was there something NASA wasn't telling us? Today, we can put those rumors to rest. The newly processed data validates what scientists suspected from the very beginning. 3I Atlas is behaving precisely like a natural comet, despite originating from the frozen depths of interstellar space. A veritable armada of spacecraft has captured the object from multiple angles, creating a comprehensive profile of our latest galactic visitor. We now have a pristine look at its behavior, its structure, and its unique chemistry. In this deep dive, we are going to explore exactly what these new images reveal, why this visitor is being called a cosmic time capsule, and what it tells us about the ancient history of our galaxy. To understand the significance of this release, we have to rewind to early July. That was when the Atlas Survey Telescope first flagged a faint, moving point of light against the backdrop of stars. Almost immediately, the object triggered alert systems worldwide. Its trajectory was unmistakably hyperbolic. In simple terms, this object was moving too fast and at too steep an angle to be gravitationally bound to our sun. It wasn't a local asteroid, and it wasn't a typical comet falling in from the Oort cloud. It was a visitor, passing through our neighborhood on a one-way trip back out into the void. This confirmation marked 3I Atlas as only the third confirmed interstellar object humanity has ever detected, joining the legendary Oumuamua and the rogue comet 2I Borisov. Unlike the rocky Oumuamua, this new visitor appeared to be active, a true comet. The timing of this flyby was both a blessing and a curse. Shortly after discovery, the comet plunged toward the inner solar system, slipping behind the sun from Earth's perspective to reach perihelion, its closest approach to our star. This is the moment of truth for any comet. It is when the heat is most intense, causing ices to sublimate into gas and creating the spectacular tails these objects are famous for. For scientists, this is the most critical window for data collection. Under normal circumstances, this event would have been accompanied by a stream of press releases and images. However, a communications freeze caused by the US government shutdown severed the public link to NASA right at the precise moment the comet was most active. This unfortunate timing created a vacuum of information, and as is often the case on the internet, that vacuum was filled by conspiracy theories. Without daily updates, observers began to wonder if the radio silence meant the object was doing something unexpected, or perhaps something unnatural. But while the public feed was quiet, the machines were still running. NASA has now released the full catalog of observations, and the diversity of the data is staggering. Humanity's robotic eyes were watching from every corner of the solar system. NASA's Mars Reconnaissance Orbiter managed to secure some of the most intimate views. As the comet skimmed past Mars, the orbiter used its high-resolution, high-rise camera to capture detailed snapshots of the visitor against the darkness of space. Simultaneously, the MAVEN spacecraft, also stationed at Mars, chipped in with crucial data from the invisible spectrum. It analyzed the comet in ultraviolet light, mapping the hydrogen gas cloud enveloping the nucleus. This data tells us exactly how the comet was breathing as it warmed up, releasing tons of water and gas every second. Meanwhile, solar observation missions like the Stereo satellite recorded wide-angle shots, showing the large-scale development of its tails as they reacted to the solar wind. Even spacecraft en route to distant targets, like the Lucy and Psyche missions, managed to snag opportunistic photos from millions of miles away. The true value of this data dump is the continuity. Rather than relying on scattered, blurry photos from ground-based telescopes, scientists now possess a continuous, multi-mission timeline. These images track the comet's evolution day by day during its period of maximum solar exposure. We can watch the coma, the fuzzy atmosphere around the core, expand and transform in real time. We can see how the tails shifted as the comet dove toward the sun and began its retreat. With the comet now drifting further away, this library of images will serve as the definitive history of its flyby. It provides astronomers with the raw material to piece together not just how the object moved, but the physical forces that shaped it during its brief encounter with our sun. Perhaps the most significant finding is that 3I Atlas behaves in a shockingly familiar way. Despite traveling light years to get here, its activity matches the physics of our own local comets. This implies that the laws of chemistry that build planets in our solar system are likely the same across the galaxy. However, there are subtle differences. Early analysis indicated a relatively high ratio of carbon dioxide to water vapor. While not impossible for local comets, it is distinctive. The newly acquired ultraviolet data will help confirm whether this chemical makeup is a trait the comet was born with or a scar from its journey. Cosmic radiation plays a massive role here. A comet drifting for billions of years through interstellar space is bombarded by high-energy particles. This transforms the surface chemistry, often creating a dark, crusty layer known as an irradiation crust. As 3I Atlas Heated up, it likely shed layers of this ancient skin. Understanding this process helps scientists distinguish between the comet's pristine inner material and the outer shell altered by eons of space travel. Another major area of focus is the structure of its tails. The images reveal asymmetrical patterns and specific dust distributions sculpted by the comet's exceptionally high speed. Because interstellar comets travel at velocities far exceeding typical solar system objects, the dust they eject interacts with solar radiation pressure in unique ways. Gas jets erupting from the surface can curve or stretch unpredictably when subjected to such high-speed motion. By comparing these patterns to those observed on the previous interstellar visitor, 2I Borisov, scientists hope to identify common traits that could serve as signatures of interstellar origin. This could help us spot these visitors even faster next time. NASA also took this opportunity to directly tackle the online theories suggesting the object might be artificial. These claims were fueled by early, raw images that appeared to show irregular, elongated shapes or fluctuating brightness. Scientists have explained that those oddities were merely standard digital artifacts. When photographing a fast-moving object from a moving spacecraft, using a camera designed for static planetary surfaces, you often get motion blur or pixelation that looks strange to the untrained eye. The newly released high-resolution frames paint a very different picture. They show a textbook comet structure, a dusty, fuzzy coma, and a bright core region. There are no lights, no structures, and no signs of propulsion. It is a natural, icy body reacting to the heat of the star it is passing. But if it's not an alien ship, it is something perhaps even more profound: a galactic fossil. Based on its velocity, significantly higher than nearby stars, researchers suspect this comet has been traversing the void for billions of years. If true, it implies that 3I Atlas formed in a star system far older than our own, long before our Sun and Earth existed. It may have been ejected from its home system during the chaotic early days of planet formation, cast out into the dark to wander alone for eons. This makes 3I Atlas a messenger from a different epoch of our galaxy's history. Studying the gases it releases gives scientists clues about the conditions within ancient planetary systems. Were early icy bodies rich in carbon dioxide? Did they hold different ratios of metals compared to our solar system? These are foundational questions about the diversity of worlds throughout the Milky Way, And visitors like 3I Atlas provide the only way to investigate them up close. Taken as a whole, these new photographs provide scientists with the most comprehensive data set on an interstellar comet since Borisov. As the comet fades from view, the work shifts from observation to analysis. Supercomputers will model the dust mechanics, and chemists will decode the spectral readings. This event has also reignited interest in future space missions. Both Oumuamua and 3I Atlas passed through our system too quickly for any existing spacecraft to catch them. We simply couldn't launch a rocket fast enough. But this has spurred proposals for comet interceptors, probes launched into a parking orbit, fully fueled and waiting. They would sit there, ready to launch at a moment's notice the second a new target is detected. As detection systems like the Vera Rubin telescope come online, we expect to find many more of these visitors. Next time, we might be ready to rendezvous with them. NASA also clarified that the comet posed absolutely no danger to Earth. At its closest point, it remained more than 170 million miles away, safely outside any collision scenario. Ultimately, the passage of 3I Atlas serves as a reminder that our solar system is not a bubble isolated from the rest of the universe. We are part of a vast, dynamic galactic ecosystem. From time to time, debris from distant, dead, or dying stars drifts through our backyard. These objects offer us a fleeting, priceless window into worlds we can never reach. The new NASA images have frozen this moment in time, providing an extraordinary record of a traveler that is already heading back into the eternal night. Thanks for watching.